for inheritance. A child can only have a single parent in object-oriented programming. But when you're using interfaces, you can implement multiple interfaces. So the display can implement the iObserver interface, but it can also implement the iDisplay interface and another interface if you want to. But that's that about that. So if you start to look at this, take a step back and think about this, it's sort of kind of starting to string together, right? Let's think about the flow of the program. How would this work? You would do what? You would instantiate a weather station. You have an instance of a weather station, okay? It is an observable, so that means it can be observed. So you have the weather station. Then you take the weather station, and then you say, okay, I want to have some displays that are notified whenever the measurements in this weather station change. Of course, we haven't talked about how the measurements in this thing changes, right? That's outside the scope of this diagram. The book gives an example, but let's just not make it too complicated, right? You can just imagine that somehow the state of this thing changes. But you have this weather station, right? The single weather station, the single observable. And then you instantiate a bunch of observers. So you say, okay, let me have the phone display. Here's the phone display. And actually, because this is a class, let me have phone display A and let me have phone display B, right? It's my phone and it's your phone. So these are two observers. And then I have a window display for the kitchen window and office window and right? So observer A, B, C, and D. So a bunch of observers, right? It doesn't matter what type they are of, right? Because they are iObservers. And what you do is then that we call add on the weather station, and we pass all of these. So we call add with this one, shoop, add it in. We call this one, add it in. And we call it with this one and add it in. So then the weather station now has some kind of collection, and the collection contains all of these. Now, what I didn't say is that when we instantiated these, we talked about this briefly before, when we instantiate these, we need to also pass a reference to this guy. So the observers need to know about the observable. So actually, I think it makes sense to start to look at actual code. So hopefully we can fit in this space, I'll try. So we start, let's redo the same thing. We instantiate the weather station. Weather station, let me just call it station. Variable name is a new weather, my God, room station. Whew. So we have a weather station called station, that's a new weather station. Then what? Then we instantiate a display. So let's instantiate a phone display. I'll only do one display, but I think you can generalize and figure out how it works for the other displays. So let's say we have a phone display. So we instantiate a phone display. Phone display, let's call it just display. And it's equal to a new phone display. And here's the kicker. It's a phone display, but in the constructor, we pass what? We pass the station. So super tiny, station. So we instantiate a phone display, and in the constructor we pass an instance of a weather station. And we're doing that, remember, we're doing that because the display somehow must be able to look at the weather station and figure out what the current state of the weather station is. Not because it's polling, not because it's asking whether the state has changed. That's what we're solving with observer pattern. But because when it knows that the state has changed, it needs to somehow access the new data. And this is why we're passing it in. Then we do what? Then we need to make use of observer pattern. We need to take the station variable and we need to use the add method because it's an observable, right? It has the add method, so we need to add this display, right? So that's what we'll do. We'll say station dot add and we pass in the display. Super simple. That means if we have the correct implementation of notify, of course. But that means that whenever notify is called, this display will be notified via the update method of the fact that the station has changed. And then we could go on. We could say station.add another display, station.add another display, station.add another display, etc., etc., etc. And then again, we could say station.notify, and then all of the observers would be notified. Of course, you could argue that notify should happen within the station rather than from the outside. But let's not worry about that right now. So that's how we would use that. Let's super quickly look at a short code example that does exactly what we've done here. We'll remove the display interface and the display methods just to sort of keep things small so that we can actually fit on this whiteboard. But let's jump into the code. So let's start off with the interfaces. So we've got an interface. So I'm using C#-like syntax. So we've got an interface called iObservable or subject in the book. And it essentially just states that you need to have the add method, which takes an iObserver, and you need to have the remove method that takes an iObserver. And depending on your scenario, of course, you might not even need the remove method. We're just trying to be exhaustive here. And then you need the notify method, and that takes no arguments. That's the interface iObservable. And then you need to have another interface for the observer. So we used to call that the iObserver. And that thing essentially just has an update method. So we have the iObservable interface and we have the iObserver interface. Then we had what? Then we had the weather station and we had the two displays. So let's first build the weather station. The weather station implements the iObservable interface. So let me switch colors. So we have a class called the weather station and it implements iObservable. It implements the interface iObservable. And we'll add those methods, but let's first do the next class. So let's only do the phone display, and then I think you can figure out that the window display or whatever other display you want to produce is essentially the same thing. So then we would have another class, a class called a phone display, which implements iObserver. And again, here you can add multiple interfaces because as we were saying before, in their example, they also implement iDisplay. So let's start with the implementation of the weather station. The weather station needs to do add, remove, notify. And as we saw before, we also have the get temperature method that's specific to the weather station and has nothing to do with observables in general. So I'm probably not going to be able to fit this on the whiteboard, so I'll have to use some heavy pseudocode, so hang with me. It's really simple actually. So the add method, let's say public void add, takes an iObserver, let's call it O, sorry, bad variable names, never do bad variable names, this is just the example. And the implementation of that method is that we add it to some list that we have in this class. So let's say that we have a list, we say this dot observers, right? Let's imagine in this class I have a list of observers. This dot observers.add, and I add this O that it was passed in, right? So the weather station has a method called add, and the method add gets an argument. When you call the method add, you call it with an argument, and that argument is an observer, and that observer instance, that observer object, you then add to a list that you have inside of this class of observers. And that's how we keep track of the observers. And that's how the observable keeps track of the observers that are observing this particular observable. So of course, that means that we also need to have the list here. So again, for the sake of space, I'll skip that, but here you would have to define that we have a list of observers. I think you can figure that out. And that's the implementation of add. And then remove is essentially the inverse of this. So I won't do remove, right? But remove essentially just say, okay, this dot observers dot remove this particular observer that I was passed in. So it's a collection. The weather station is a collection of observers. You can pass in observers that you add to the list, and then you can call remove to remove observers from the list, or rather more generally the collection. But more interestingly, we have the notify method. And the notify method is really simple. What we do is essentially, let's just say public void notify. So sorry, here I used lowercase and here I used uppercase, but you'll figure it out, apologies. Notify takes no arguments. And what's the implementation of notify? The implementation of notify is that we say for each iObserver, let's call it O, in my list of observers in this dot observers, for each of these observers, do what? O, the observer, dot update. Because each observer has a method called update. And that's how we notify. So when you call notify, let me close this curly brace. When you call notify on the weather station, you iterate over all of the observers in the collection this.observers, in the collection observers that we defined here in the weather station. So the weather station has a collection of observers. You iterate over the collection of observers and then you call update on each of those observers. And this is the heart of the observer pattern. If you get that, you get the observer pattern. And of course, we talked before about how the weather station needs to have some method that makes it possible to access the data that's in there. So we also need to have, let's say that the temperature is returned as an integer. So we have a method public int get temperature. And we haven't built that. We would need to define an instance variable here that holds the temperature or something like that. So let's assume that we have that, or let's pretend that we have that. Then I would say something like return this dot temperature, right? So when you call get temperature, you get an int back, which corresponds to the temperature of the weather station at that particular time. Let's close this curly braces. So that's essentially the implementation of the weather station. And then what's the implementation of the displays? Well, the displays essentially need to have the update method. But the crux is, remember that we've talked before about that constructor. So now we need to actually build that constructor. So let's build a constructor of the phone display. So let's say public phone display, and here's the key. It takes an argument. And that argument is of what type? It is of type weather station. So it takes a concrete weather station. And again, I mean, don't freak out about coupling to concretions. There's probably a better way to do this. Yes, let's dig into that some other time. But coupling to the concretion weather station here is less bad than if we would have coupled to the concretion weather station here. Because at least then you have an abstract ancestor up here that isn't coupled to the concept of weather station. But when we have a concrete phone display, that's suddenly a phone display for weather stations. So it's not really, to me, it doesn't really feel that bad that we're coupling to a concrete weather station, right? Because you can think of it in terms of the semantics, right? You can think about how a phone display isn't a display that displays anything, right? In this particular scenario, we're modeling a display that displays weather station data, and thus it can couple to the concretion weather station. If we want to model a display that can display anything, we need to increase abstraction and get rid of the weather station. But that's not relevant for this example, so let's move on. So we pass in the weather station, let me call the variable name station, and I'll open the constructor. And what's the implementation of the constructor? Essentially, we'll just save this parameter that we were passed in. So we say this dot weather station, actually, to save space, let's say this dot station is equal to the station that we passed in. And it's important to realize that what we're doing is that we're setting the variable, the value that we've passed in through the constructor, that's this value. We're taking that value and setting it to a variable that we have in the scope of this class, in the scope of this instance. So we have an instance variable here called of type weather station. Man, this is totally messy, I apologize for that. We have an instance variable here called weather station. So it's that variable that we're setting when we're passing this in here. If that doesn't make any sense to you, please be sure to check out my previous video on strategy pattern where I make that more clear. But we're essentially passing something in, dependency injections through the constructor, and then setting that on the instance level. So now that we have that station, what's next? Well, then what's next is to implement the update method. So let's implement the update method. So the update method says, okay, we have a public void update, takes no arguments. And what's the implementation? Think about when update is called. Update is called here. Update is called whenever the weather station wants to notify all of the observers. When somebody calls notify on the weather station, all of the displays, their update methods are called. The update method of all of the displays is called. So this update method is called whenever there is an update. It's essentially called whenever something has happened in the weather station that somebody has deemed important enough to update. And here's the thing that we talked about before. If we didn't pass in the station to the constructor, if we didn't do that, what would we do here? We would know, aha, okay, the weather station has some new data, I know that. But what am I going to do with that data? Because I can't access that data. So because we passed in the station through the constructor, we can now actually access that and say, okay, this dot station, not this station that we passed in through the constructor, but the one that we saved on the instance level, the one that we saved into the instance. So we have access to that station, and then we can say this dot station dot get temperature. Boom. Because we defined get temperature here. So because we're accessing it as a weather station and not as an iObservable, we can have access to the method get temperature, because get temperature is defined on the weather station and not on all observables. Right? So here we're actually coupling to the concretion so that we can get access to the get temperature method. So you instantiate the weather station, you instantiate the display, and when you instantiate the display, you pass it the instance of the weather station in here. And then we take this display instance and we pass it in a call to add. So we call add on the weather station and pass it the instance of the display. When we do that, when we call add on the weather station and pass it an observer, what the weather station does is that it implements the add method that the iObservable asks it to implement. And the implementation is essentially that it has a list of observers and it takes the observer that it was passed in and it adds this observer to its list of observers. And semantically, why it does that is that because it wants to be able to notify that observer whenever something changes. And then at some point later, something changes, right? We haven't covered how or why something would change, but essentially we have the notify method. So regardless of whether the weather station itself calls the notify method or whether somebody else calls the notify method, when the notify method is called, what the weather station does is that it for each, it loops through, it iterates through its collection of observers, the observers that it has in this dot observers, and this collection is the one contains the observer that we passed in before because we call the add method and we added in that observer. So we have this list of observers and we iterate through that list of observers, and for each of the observers we say dot update. And when we call update on that observer, we're in here, we're in the phone display, because that's an observer, and we've added the observer to the weather station, to the observable. And when we then get a call to update, right? When they send the message, when the weather station sends the message update here, then the phone display knows that, aha, something has changed and I can now update my display or whatever this thing wants to do, right? If it's a different scenario, if it's a subscriptions, right? Maybe this is an article reader, and we know when we call update, we know that there might have been a new article in the database of articles, so I need to update my list of articles that I have here in the display or whatever this is, or the web page or whatever. When I get that call to update, I know that something has happened and I need to react to this, right? Because that's why I subscribed, because I wanted to be able to react to this. And how I get information from the weather station is through the reference that I have in this dot station, because when I created the display, I passed in a weather station, a concrete weather station. I passed it in through the constructor and saved that as an instance variable. And now I can access that instance variable and call whatever methods I need, such as get temperature, in order to do whatever is relevant to do in this scenario. Period. So I'm guessing either that was super overly clear or totally confusing. Please let me know which one. Before we wrap this up, let's get back to the UML diagram. So hopefully now this diagram makes 1000% sense. Let's look at it. We have an interface iObservable that has 0 to many observers, iObservers, which is also an interface. The interface iObservable has the methods add, remove, and notify. Add takes an iObserver so that it can save a reference to that observer so that it can notify these observers whenever it undergoes some kind of change that the observer should be interested in. Remove does the inverse of that. It takes an observer and removes it from the list of observers that the observable has. Notify essentially says, okay, I've got this list of observers, let me now call update on all of these observers. Something has happened, let me notify all of the observers of the thing that has happened. Or of that, something has happened and that they should look into me to get the data that they're interested in, because something has changed. And that's on the abstract level. On the concrete level, what do we have? We have a concrete observable, and the concrete observable essentially just implements the methods that we talked about, right? This is actually just a contract. It says that to be an iObservable means that you need to specify these methods. You need to be callable in these terms. And the implementations that we talked about actually live here in the concrete observable. So this is where we actually implement add, remove, and notify. And same thing for concrete observer. If you have a concrete observer, then the update method depends on what your observer actually does. Think of in terms of the displays. You have the LCD display or the window display, and we have the phone display. And they might do completely different things. Or maybe you could think of it this way. Maybe you have a web display and a file display. So one produces a file, like a PDF file, and one produces a web page. And the logic in these two methods would be completely different. A lot of overlap, but also completely different. So that's why the update method, the implementation of the update method lives in the concrete observer. And then we have the method getState, because the particular flavor of observer pattern that we looked at here is one where you push the fact that you have a change, but the observers have to pull data, I should do this, pull in this direction, pull data from the concrete observable. There are variations of observer pattern. Let me know if you want us to discuss this, and we'll dig into that in a different video. But there are variations of observer pattern where instead of forcing the clients to have to pull data, right, you push data through the update method. And this, we touched upon this before, right? Instead of just having an update method that doesn't take any arguments, you send the message update with some data that the observer should be interested in. that means that the observer, remember how we passed the observable through the constructor to the concrete observer, that means you don't have to do that. That means that the observer doesn't need to have a reference to the concrete observable, which essentially in terms of this UML diagram means that this arrow disappears. It means that the concrete observer does not need to have a concrete observable, because whenever you call update, the concrete observer gets not only notified, but also gets the data that it should be concerned about. So then it's kind of a push-push. You're pushing the fact that there has been a change, but you're also pushing the data that the observer should be interested in. What we've looked at here, when we still have this arrow, is more like a push-pull. So you push the fact that there has been a change, but then the observer has to pull data from the observable. But if we rewind all the way back to the beginning, where we started with the discussion about push versus pull, notice how I'm saying pull and not pull. So what we're saying here is that data has to be pulled, but it's still better than having to pull for changes. The implementation that we have here is kind of push-pull, but when we talk about a pull implementation, we talk about pulling for changes, we're talking about a pull-pull or a pull-push. Pulling essentially means that the first step, the idea of knowing whether there has been changes, that step is carried out via pull, right? Is carried out by the observer asking the observable whether it has changed. But if you're always asking whether it has changed, you can't know certainly when it has. But in that kind of implementation, you have to continuously keep asking in order to be notified at the correct time, because you never know whether it has changed or not. So you just have to keep on asking and asking and asking. And sometimes it has changed and sometimes it hasn't. But when you do a push-push solution or a push-pull solution that we looked at here, then you don't have to keep on pulling, because you register your interest. The observers register the fact that they want to be notified, and then they're notified. So now I'm really smashing this in too much and I'm sort of iterating. So let me know if that was helpful, or if you're looking for different kinds of information, if you want me to sort of twist these things in different ways. I'd love to listen to you. Your opinion matters greatly to me, so shoot that in the comments. The link to this book is in the description. Be sure to check it out. We've got tons of patterns to go, so remember to subscribe if you're not already subscribed. Thanks for watching, and I'll see you in the next one.